All right. We are in section 6.5, where we're going to prove triangles are similar by side, 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 and side, angle, side. The first one we're going to take a look at is the side, side, side similarity theorem. The similarity theorem states that if corresponding side lengths of two triangles are proportional, then the triangles are similar, okay? So we have to make sure that the corresponding sides are similar for all three of them. So if we can prove that if the ratio to AB over RS equals BC to ST and CA equals TR, then we can say that the triangle is similar by SSS. The other one is side angle side theorem. It says if an angle of one triangle is congruent to an angle of the second triangle and the lengths of the sides including these angles are proportional, then the triangles are similar. So basically what they're saying is they're saying when angle X and angle M are equal, the sides that share that angle must be proportional. So like you couldn't say that like these ones are proportional. You couldn't prove that. You had to make sure that the sides that share the angle are proportional in order to prove that the triangles are similar by, so you can't do that. All right, so that's not allowed. So the only way that you can show proportions is the sides that share that angle. So in this case, the sides that share angles X and M respectively would be X and Z and X and Y, MP and MN. Another thing to note, we can only prove triangles are similar by angle angle, which we talked about in 6.4, side side side, or side angle side. So how do we use the side side side, or SSS? All right, first thing we have to do is, does it tell you or show you all the side measurements? If it does, make sure each corresponding side is proportional. If we're going to use the side angle side, the triangle must show us angle measure and side length between the angle measures. All right. If it doesn't show us the angle measure, maybe we have to take a look at other properties. So like the reflexive property and the vertical angles property are important in this particular instance, because even though they don't show us it directly, we can use those properties to say, yes, those angles are congruent. And then you're going to make sure the angles are equal and the corresponding sides are proportional. So what we have here for the first example is they want to know is either triangle DEF or triangle GHJ similar to triangle ABC. So right off the bat, we notice that they give us all the angle measures. So the only way that we can prove that these triangles are similar is by side, side, side. So we have to make sure that they're proportional. So what I'm going to do is I have triangle ABC. So I got this AB. I want to see if it's proportional to BC, which is 12. It's proportional to AC, which is 16. All right, first off, I'm going to use DEF. So they said AB, that's first and second letter. And so DE is first and second letter, so that means it's got to be 6 is written here. BC is second and third. EF is second and third in this one, so that means that this has got to be 9. And then finally, first and third, it is AC, and DF is first and third, so I gotta say that this is 12. So now what I get to do is reduce them. So 8 over 6 in lowest terms is 4/3. 12 over 9 is 4/3. And 16 over 12 is 4/3. So since they're all proportional, I can say that triangle DEF is similar to triangle ABC. And just for fun, let's see if triangle GHJ is as well. So I'm just going to put the 8, 12, and 16 just like I did for the first one. And so for the first and second letter, it would be G and H. G and H would be 8. And then HJ would be 10. And then finally it would be what, 16. So already here I got 1. And then 12 over 10 would be 6/5. So these aren't proportional. So I can't. So that particular triangle is not similar. Okay. Same rules apply. They want us to show that the triangles are similar and write a similarity statement. And they're asking us to explain. All right, the explanation is if it's side, 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 show that the sides are proportional. If it's side, angle, side, give me an angle that's congruent. Give me two angles that are congruent, and then show proportions. So that's what I mean by explaining it. So right off the bat, they don't give us all the sides because they don't give us this side here. So that we're uncertain about that. But like I said in the previous page, to remember about reflexive properties and vertical angles. This is an opportunity where we can say that, oh, we have a reflexive property because angle KRJ is congruent to angle TRS because of the reflexive property. So I know that that angle is going to be congruent, so angle KRJ is congruent to angle, we'll say, TRS. So the last thing we have to do is prove that the side lengths are proportional. So I'm going to put the smaller triangle in the numerator. So I'm just going to say 27 over, and you have to add up the two angles. So 27 plus 13 gives me 40. I got to see if 18 over 18 plus 12, which is 30, I got to prove that that is proportional. So if I take 27 over 40 and I reduce that, it gives me 27 0. So if I multiply, so 40 times 18, right now I'm just cross multiplying, and 27 times 30 is 810. Let's see. As right now, it's looking like they are not proportional, but they may not be true. Let's take a look at this. Let's try to put all right, sorry about that. I guess this, because they're not proportional, I can say that this is not similar. Because the reason for that is they told us that that's not parallel, and I can't prove that by angle. Okay. And let's take a look at this one. Angle A, or not angle, triangle ABC and triangle XYZ. They give us all of the side measurements. So with that, the only way that we can prove that is by side, 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 and we have to prove that the corresponding sides are proportional. So I get I'm just going to take the largest side, which is 32, and I'm going to go over the largest side, which is 24. I'm going to set it proportional to the second largest, which was 20 over 15, and I want to see if 16 over 12. So I go over here, and I need to reduce 32 over 24, and that gives me 4/3. And 20 over 15 is also 4/3, and 16 over 12 is also in fact 4/3. So since they're all the same ratio, means they're proportional. So I can say yes, because of side, side, side. I'm going to say triangle A, B, C is similar to triangle. So it'll be what? X, Y, Z. Okay. Let's take a look at this example. So we have a triangle, two triangles here, and they don't give us all of the side length information, so we're going to have to use side angle side, because we can't use angle angle because we can't prove that any one of those sides are parallel. But I can take a look here. Those two angles are congruent because of vertical angles, and that means we have to see if the sides are proportional. So I'm going to use 18 over 30, so the longest side and the longest side. I want to see if it's proportional to, would be what, 9 over 15. So I got 18 over 30. I reduced that. That gives me 3/5. And then I got 9 over 15. That is also 3/5. So angle is congruent because of the rate. So I'm just going to say angle ACB is congruent to angle DCE because of vertical angles. So because of those two things, we can say because of side, angle, side, triangle ACB is similar to triangle DCE. And then finally, we have these two triangles here. They give us the angle measure here and here. And what I would probably do in this situation is turn it over so it kind of looks like it's the same thing as the right triangle. So I'm just kind of mimicking this triangle. So it's a 32. So that's value P. If you turned it upside down, so N would be over here and M would be here. So P to N would be 6, and then P to M would be 5. So the angles are congruent. They already tell us that. But now we have to prove that 8 over 6 is proportional to 7 over 5. So if I were to reduce that, 8 divided by 6, I get reduced to 4/3, and 7 divided by 5 is just 7 over 5. So those do not work. So even though the angles are congruent, that one angle is congruent, the sides are not proportional, so this is not similar. And then the last thing we had here was, this is a little discussion, is why is there no side angle theorem? And we talked about in class, the reason for that, the best way that you can prove that something isn't is just by showing one example where it would not be true. So you could have a side, call it 3, and then you had another side and you had it as 2, and you had an angle which was, we'll just call it congruent. But we know that if you were to put it at, you could put it as a side here, which would be 3, and a side here, which would be 2, and even though the sides and the sides are the same, you couldn't get the same angle. So this is kind of the proof by contradictory, or proof by default, or proof by, being able to prove something doesn't work shows the proof. So can't use side, side, side angle. And this is being able to prove triangles are similar by side, 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 and side, angle, side. Hope this helps. Until next time.